Now we are discussing the next lecture of unit number 5, that is problems on earth pressure. So problem number 5, that is a retaining wall of 7 meter high retains sand. The properties of a sand are E equal to, E means the wide ratio 0.5, phi equal to 30 degree, that is in angle of internal friction, and G, that is specific gravity 2.7. By using Rankine's theory, determine the active earth pressure at the base when first case when the backfill is dry, second case when the backfill is saturated, third case when the backfill is submerged, and also calculate resultant active force in each case, in addition to determine total water pressure under the submerged condition. Okay, total water pressure under the submerged condition. Okay, so this is our figure. Okay, so this is the data. So total height is 7 meter, E equal to 0.5, G equal to 2.7, phi equal to 30 degree, backfill is submerged for dry and saturated. We have to calculate the active earth pressure. Okay. So first of all, we have to calculate the values of the unit weights, that is gamma D, gamma saturated and gamma submerged. By unit number 1, okay, by introduction and index properties, we had already learned the formulas. So first formula for dry unit weight, we know the formula, dry unit weight gamma D equal to G gamma W upon 1 plus E. So the G is specific gravity, that is 2.7, in gamma W, that is unit weight of the water, that is 9.81 upon 1 plus E. E is a wide ratio, that is 1 plus 0.5 equal to 17.66 kilonewton per meter cube. This is the value of gamma D. Then for saturated unit weight, we have formula G plus E, that is bracket G plus E gamma W upon 1 plus E. So G is 2.7, E is 0.5, that is 2.7 plus 0.5 into gamma W, that is 9.81 upon 1 plus E, that is 1 plus 0.5, that is wide ratio. Our answer will be gamma saturated, that is 20.90 kilonewton per meter cube. Similarly, calculate the submerged unit weight, that is gamma submerged equal to gamma saturated minus gamma W, that is 20.92 minus 9.81, that is 20.94 is the saturated unit weight minus unit weight of the water, that is 9.81. So our value of submerged unit weight is 11.1. So now calculate the value of active earth pressure coefficient, that is Ka, that is coefficient of active earth pressure, that is 1 minus sine of phi upon 1 plus sine of phi, that is 1 minus sine of 30 upon 1 plus sine of 30, that is 0.33. Now put all these value in the formula. We have formula because we have to calculate the pressure at the base. Okay, pressure at the base formula will be, because here are at the base means we have calculating all this pressure at this level. If you want to calculate at the total retaining wall, so it will be act at somewhere at h by 3, because it is a triangle. Okay, it is acting at centroid. Okay, so now we have to calculate only at this base level. Okay, we have to calculate at this base level only. So for dry backfill, we know the formula. So total earth pressure, we know the formula, that is 1 by 2 Ka gamma h square. For the base formula will be Ka gamma h. So for dry backfill, we have using dry unit weight, that is Ka gamma D into h. So Ka, value of Ka is 0.33, gamma D is 17.66. Okay, gamma D is 17.66, barabar na, 17.66, and the height is 7, so we get the answer, that is 41.2 kilonewton per meter square. Then calculate for saturated backfill. So formula is 1 by 2 Ka gamma h square. For the base formula will be Ka gamma h. So here gamma, we can use gamma saturated. So Pa equal to Ka gamma saturated into H, that is Ka is 0.33 into gamma saturated, that is 20.9 into 7, that is 48.76 kilonewton per meter square. And last one for submerged backfill, PA equal to Ka gamma submerged into H. Okay, this is for base only, and if you want to calculate for total wall, formula will be 1 by 2 Ka gamma 1 by 2 Ka gamma submerged into H square. So here is for base Ka gamma submerged into H. So Ka is 0.33, gamma submerged is 11.1 into 7. So our answer is 25.9 kilonewton per meter square. So the last problem, for the earth retaining structure which is shown in figure, construct pressure distribution diagram for active case and determine total thrust per unit length of the wall. So this is the figure. Okay. So there are the two levels. First is so this is only dry case, and this case there will be the sand as well as the water. Okay. So here is a water table. So this is a partially submerged backfill. So this in this case, this is first height, that for 3 meter. For the 3 meter there will be only soil, there is no water. Second case there will be, this is groundwater table, means soil plus water. Okay, soil plus water, and in addition to that there will be surcharge. Okay, this is surcharge, is like a uniformly distributed load. Okay, we have shown UDL is like that also. Okay, or you can write it as also. Okay, its intensity is 14 kilonewton per meter cube. Total height of the retaining wall is 10. Okay, so there are two layers. So this is called as H1. So we can call as H1 equal to 3 meter, and H2, that is remaining part, that is 7 meter. Okay. Okay. So this is a pressure distribution diagram. So this is pressure distribution diagram. So this is a P1 force which is divided into number of parts, P1 force, then the P2 force, and P3 force, and P4 force. Okay. So the P1 force is due to, this is the P1 force, this is the P1 force, that is okay, this is P1 force. So this is the pressure, first pressure distribution diagram, this is the second pressure distribution diagram. Okay, this is the second pressure distribution diagram. So sorry, this is a third pressure distribution diagram, and this is a fourth distribution diagram. This is fourth, this is third, this is second, and this is 1. Okay, 1, 2, 3, 4. So now we have to calculate all these. First of all, we know the values of unit weights. From that we can put the values in our formulas and then solve the problems. So, so our given data, White's ratio E equal to 0.65 and G is 2.65 is given. Phi is also given, that is angle of internal friction, that is 30 degree. So as we know, dry unit weight gamma D equal to G gamma W upon 1 plus E, that is G equal to 2.65 into gamma W is 9.81 upon 1 plus 0.65, that is 15.7 kilonewton per meter cube. And submerged unit weight, okay, formula will be G minus 1, gamma submerged equal to G minus 1 gamma W upon 1 plus E, and or you can use gamma saturated minus gamma W, but there is no gamma saturated weight is given. So here we have using formula, that is G minus 1 into gamma W upon 1 plus E. So that is G is 2.65 minus 1, gamma W is 9.81 upon 1 plus 0.65, that is equal to 9.81 kilonewton per meter cube. So now calculate the value of Ka, that is 1 minus sine of phi upon 1 plus sine of phi, that is 1 minus sine of 30 upon 1 plus sine of 30, because phi is 30. So Ka equal to 0.33. So now calculate all the pressures, active earth pressure, that is P1, P2, P3 and P4 according to pressure distribution diagram. So here we are assuming that soil above water table means this is our water table, GWT means groundwater table. So this this GWT means the groundwater table. So, soil above groundwater table assumed to be dry. So, that means this portion is assumed to be dry. So, this is the dry portion. Okay, this is the dry portion. We have to assume as a dry portion. So, first of all calculate P1, because we have calculating all these pressures at the base. So, formula will be at the dry case Ka gamma H1. If you want to calculate total pressure, formula will be 1 by 2 Ka gamma H1 square, but here we are calculating only at the base level. Okay, means it means at this level, this is base level. So, here we are calculating the pressures. Okay, so formula will be, so P1 will be Ka gamma D H1, because so H1 is H1 height means the height of dry soil. Okay, because we are assuming height above the water table is dry. So, Ka that is 0.33, gamma D that is 15.7, and H1 that is 3. So, our value is 15.7 kilonewton per meter cube. Then calculate the second pressure at the base. So, Ka into gamma submerged, because for second case we have to calculate the value for submerged unit weight. Okay, because H2 is height is at this level. This is the H2 which contains, H2 means 7, and above at this, that is H1. This is the dry, and this is contain water, that is submerged condition. Okay, so here we are using for second case H2 as 7 meter. Okay, so Ka that is 0.33, gamma submerged that is 9.81 into H2. So, into H2 is 7. Okay, this is wrongly I have written here. Here is 7. Here is 7. Okay. So, once again I am repeating, I think the recording will be stopped. So, for the first case, this is the first triangle. So, this is base is P1, height is H1, that is 3 meter. So, area will be 1 by 2 P1 into H1, that is 1 by 2 P1 into 3, H1 is 3. Okay, this is for first triangle. Then for this second is a rectangle. Okay, second is a rectangle. So, rectangle, so base is P1 and height is H2, because this height is H2 na, H2 that is 7 meter, that is P1 into H2 is the area, P1 into S2 is the area, that is P1 into S2 is 7 meter, S2 is 7 meter. Then for the third triangle, this is for third triangle. Okay, this is third triangle. So, third triangle, so this is for third triangle, this is third triangle. So, here base height is P2, so base is P2, height is H2. So, we have to calculate area. So, area will be 1 by 2 P2 H2, 1 by 2 P2 H2, 1 by 2 P2 H2. So, H2 is 7. Okay. And then for the next one, the next figure, that is this figure. Okay. So, this figure we can calculate by P3, because this is whole is for P3 na. Okay, whole is for P3. So, this is P3 and there are two heights. This is the first height and second is at the top there is second height. Okay. This is okay. So, we have to add this height, means we have to taken as, instead of this inclined portion we have to taken as straight one. So, this is 3, this is 7 and this value is P3, this value is P3, this value is P3. So, our area will be P3 into 10, or we can also write as P3 into H1 plus H2. So, H1 is 3 and H2 is 7. Okay. Now, last one, that is last triangle. So, this is a last triangle. Okay. So, this last triangle is of P4, na? Is of P4. So, this is P4 and this height is H2. So, our area will be 1 by 2 P4 into H4, 1 by 2 into P4 into H4. Okay. Note that this is triangle. So, now putting the values. So, these are the right up, that is 1 by 2 P1 into H1, that is 1 by 2 P1 is 15.7 into 3 because first is triangle, second case, second is rectangle, that is P1 into H2, that is 15.7 into 7. Third is a triangle, that is 1 by 2 into P2 into H2, that is 1 by 2 P2 is 22.7 into H2 is 7. Third is for surcharge. Okay, we have divided into two parts, that is first height and second height, and making a triangle, making a rectangle, that is P3, that is 4.66 and height of the rectangle 7 plus 3, or sorry 3 plus 7, 3 plus 7, 3 plus 7 plus 1 by 2 for last is a triangle P4 into H4, that is 68.7 into 7. So, by solving all these terms we get the answer 501 kilonewton per meter. Okay. So, this is all your syllabus of unit number 5. So, in that unit number 5 you have to remember simple formula for level pressure, that is 1 by 2 Ka gamma H square. It is simple formula. So, it can be modified into various according to various backfill conditions. If the backfill is your leveled backfill, formula will be 1 by 2 Ka gamma H square. If the backfill is layered backfill, so this formula, same formula will be divided into two parts, the first part and second part. But note that the values of internal friction and gamma will be there. So, formula will be changed, that is Pa1 and Pa2, that is 1 by 2 Ka1 gamma H1 square for first layer, and for second layer 1 by 2 Ka gamma 2 H2 square for second layer, and for all other cases same formula will be there. But according to pressure distribution diagram we have to create the formula. And one another important point is when we calculate passive earth pressure we have to remember the same formula, we have to remember only formula for active earth pressure. You need not remember the formula for passive earth pressure. Okay. The only difference between active and passive is that for active earth pressure formula is Pa, symbol is Pa, and passive earth pressure is Pp. And second change is for coefficient of active earth pressure, that is Ka equal to 1 minus sine of phi, and for passive earth pressure that is P equal to 1 plus sine of phi upon 1 minus sine of phi. And for backfill is inclined, formula will be different for active case and passive case. And when there is a earth pressure at rest, the formula for earth pressure at rest is same, that is 1 by 2 K0, here is K0 gamma H square. So, K0 is 1 minus sine of phi only, K0 equal to 1 minus sine of phi only. Okay, it is limited into 1 minus sine of phi, there is no any denominator for that. Okay. And you have to remember the large formula for the sloping backfill, because it is mostly asked in your online examination or your competitive examination. That is, what is the formula for coefficient of active earth pressure for sloping backfill or passive earth pressure for sloping backfill. Okay, so your formula, that is cos of delta into cos of delta minus under root of cos square delta minus cos square of phi upon cos of delta plus under root of cos square delta minus cos square phi. So out of that, cos of, that is delta means surcharge angle, or it is inclination of a backfill to with the horizontal. It is angle of inclination with the horizontal, and phi is angle of internal friction. Okay, so most of cases value of phi is given as a 30 degree. So you can directly write down the value of k as 0.33, because if you calculate the value of k equal to 1 minus sin of 30 upon 1 plus sin of 30, it answer will be 0.33 or 1 by 3. Okay, you can calculate by using calculator, you can calculate. Okay, see, in the most of the problem while I am studying while I am SD3, at that time the same formula will be there, and most of cases the value the angle of internal friction, that is phi is 30 degree is given in the most of the problem. Okay, so its answer will be 0.33 or 1 by 3. Okay, thank you. And now for next lecture we have discussed about the unit number 6.